Brain Rules, 12 Principles for Surviving and Thriving at Work, Home and School, by John Medina. Introduction. Imagine a man, 70 years old, standing at the edge of Long Beach Harbor in California. He's not there to watch the boats. He's about to do something most people would call impossible. He's handcuffed, shackled, and fastened to a cable. At the other end of that cable are 70 boats, each with a person inside. And then, he begins to swim. Battling strong currents, he pulls all 70 boats, and all 70 people, for 1.5 miles across the harbor. The man's name was Jack LaLanne, and he wasn't just a strong man, he was celebrating his 70th birthday. Even more remarkable than his physical strength was his mind. Well into his 90s, he was mentally sharper, wittier, and more full of life than people a third his age. His story leaves us with a profound question. Is there a link between a healthy body and a healthy mind? And if so, what other secrets does our brain hold that we've completely overlooked? For centuries, the human brain has been the most mysterious object in the known universe. It's an intricate 3-pound universe tucked inside our heads, responsible for every thought, every feeling, every memory we've ever had. Yet, for most of us, it comes with no instruction manual. We live our entire lives with this incredible machine, but we have no idea how it works. That's the puzzle that drive. John Medina, a developmental molecular biologist, set out to solve for us. He spent his career studying the intricate dance of genes and molecules that build our brains, but his real passion was bridging the enormous gap between the world of brain science and our everyday lives. He noticed something strange. The places where we are supposed to do our most important thinking, our schools and our workplaces, are often designed in ways that are directly opposed to how our brains are built to learn. It's as if we were given a high-performance race car and were told the best way to drive it was to keep it in first gear and never change the oil. So, he wrote Brain Rules. This book isn't just a collection of interesting facts, it's a user's guide to the human brain. It's based on decades of rigorous, peer-reviewed science, translated into simple, powerful principles we can use to transform the way we work, learn, and live. By the end of our journey today, you'll understand why trying to multitask is like trying to pat your head and rub your stomach while solving a calculus problem. It's literally impossible for your brain's attention systems. You'll discover why exercise might be the single most powerful tool you have for boosting your intelligence. And you'll see why a simple, 26-minute nap could make you 34% better at whatever you do. My promise to you is this: you're about to be handed the owner's manual you never knew you were missing. Let's begin. Book summary. To understand the rules of the brain, we have to go back in time. Way back. Not just a few hundred years, but millions of years, to the grasslands of the Serengeti. The story of our brain begins with a simple, 2-word fact that every scientist on the planet agrees on: we moved. A lot. Our ancestors didn't spend their days sitting in classrooms or cubicles. They were walking, sometimes up to 12 miles a day, across an unstable, unpredictable outdoor world. Our brain, this incredible thinking machine, was forged not in a library, but in the wilderness, in nearly constant motion. This is what drive. Medina calls the brain's performance envelope. It's designed to solve problems related to survival, in an unstable environment, while moving. Every single rule in this book flows from that simple truth. This brings us to the very first, and perhaps most important, brain rule: exercise boosts brain power. When you think of exercise, you probably think of building muscles or improving your heart. But the most profound effects of exercise are on your brain. Remember Jack LaLanne? His story isn't just an anomaly, it's a living demonstration of what science has now proven. When we move, our blood flow increases across the body, and that includes the brain. This brings it two things it desperately needs: glucose for energy, and oxygen to clean up the toxic byproducts left over from all that thinking. Think of it like a world-class delivery and janitorial service for your head. But it gets even better. Exercise also stimulates the production of a protein with a wonderfully scientific name, brain-derived neurotrophic factor, or BDNF. The best way to think of BDNF is like Miracle-Gro for your brain cells. It keeps existing neurons healthy and encourages the growth of new ones, especially in the hippocampus, a region critical for memory and learning. The research is stunning. A lifetime of exercise can lead to an astonishing improvement in cognitive performance, in memory, reasoning, attention, and problem solving. What's more, it's one of the best forms of preventative medicine we have. Regular aerobic exercise, just twice a week, can cut your risk of general dementia in half. And it can lower your odds of getting Alzheimer's by more than 60%. We've designed our modern world around sitting still, but our brains are crying out to return to their Serengeti roots. We weren't built to sit at a desk for 8 hours a day. We were built to move. This ancient past didn't just shape our need for movement, it shaped the very structure of our brain and our unique way of thinking. This leads us to our second rule: the human brain evolved too. If you look inside your head, you don't have one brain, you have three, layered on top of each other like an archaeological dig. At the very bottom is the lizard brain, the brainstem that controls our basic survival functions like breathing and heart rate. Wrapped around that is the mammalian brain, which handles our emotions, our memories, and the 4 F's: fighting, fleeing, feeding, and reproductive behavior. And then, like a thin, wrinkled blanket covering it all, is the cortex, the human brain, the seat of our logic, reason, and all our most complex thoughts. So what made our brain so special? When climate change forced our ancestors out of the trees and onto the savanna, we faced a choice: get stronger or get smarter. We chose smarter. Instead of growing bigger muscles, we grew bigger brains. And that new brain power gave us a secret weapon, something no other creature on Earth possesses in quite the same way: symbolic reasoning. It's what my son Noah did when he was 4, picking up a stick and declaring, "That's not a stick. That's a sword." He saw one thing but knew it could represent something else entirely. This ability to make one thing stand for another is the foundation of everything that makes us human: language, art, mathematics, and culture. We are human because we can fantasize. But perhaps our greatest evolutionary trick was learning to cooperate. On our own, we were weak. But together, we could take down a woolly mammoth. To cooperate, we needed to understand what others were thinking and feeling. We developed an ability called theory of mind, the capacity to peer inside someone else's head and guess their intentions. This social intelligence, this deep need to connect and predict the behavior of others, may be the very thing that drove the massive expansion of our brains. It means that, at our core, we are built for relationships. And this brings us to a critical point about learning. If you don't feel safe with your teacher or your boss, you may not be able to learn or perform as well. Learning isn't just an intellectual activity, it's an emotional one. Our brains evolved to learn from people we trust. This deep history not only explains why we learn, but how we learn. Which brings us to a fundamental misunderstanding most of us have about our own minds. When you learn something, where does it go? Does your brain act like a video camera, perfectly recording an event for later playback? Not even close. The truth is, the moment information enters your brain, it's like it's been put in a blender with a lid off. The information is sliced into pieces and splattered all over the cortex. The sights, sounds, and smells of an experience are all stored in different parts of the brain. For example, your brain doesn't even store vowels and consonants in the same place. This is the opposite of a recording. It's a reconstruction. Every time you remember something, your brain is reassembling that fragmented information. And this leads to the third rule: every brain is wired differently. What you do and what you learn in life physically changes what your brain looks like. It literally rewires it. The brain of a violinist looks different from the brain of a basketball player. The regions controlling the complex finger movements of their left hand become enlarged and more complex, like a muscle that's been worked out. This wiring is happening all the time, and it's unique to you. Not even identical twins, who share the exact same DNA, have identical brain wiring. Why? Because from the moment they are born, they have slightly different experiences. They see the world from slightly different angles. They learn different things at different times. Every second of your life, your experiences are sculpting a brain that is unique in the cosmos. There is no such thing as a standard brain. We each have different strengths, different ways of being intelligent that don't always show up on an IQ test. Our school systems, however, are often built on the idea that every 10-year-old brain should learn the same way and at the same pace. But brain science tells us this is fundamentally wrong. It's like expecting every player on a basketball team to be a great three-point shooter. Some are better at defense, some are better at passing. It reminds me of the story of Michael Jordan, perhaps the greatest basketball player of all time. In 1994, he decided to quit basketball and play professional baseball. He failed miserably. His brain was wired for the split-second decisions and movements of the basketball court, not for hitting a curveball. The lesson is profound. We need to create environments, in our schools and workplaces, that honor this diversity, that help people play to their strengths instead of forcing them into a one-size-fits-all model. So, if every brain is different, and if learning is this chaotic process of reconstruction, how do we get anything to stick? This brings us to the engine room of learning, attention, and memory. Let's start with a rule that everyone intuitively knows, but consistently ignores. We don't pay attention to boring things. Your brain is constantly being bombarded with millions of sensory inputs every second. It has to make choices. It has to decide what's important and what's not. And what gets the brain's attention? Emotion. Think about the most vivid memories you have. I bet they're tied to a strong emotion: joy, fear, surprise. Emotionally charged events act like a chemical post-it note for our brains, releasing dopamine that says, "Remember this." Drive. Medina tells a harrowing story of waking up in the middle of the night to find an intruder in his house. The experience lasted only 45 seconds, but the details are burned into his memory forever. Emotionally competent stimuli, as scientists call them, are the most well-processed information we ever encounter. This is where most lectures and presentations go wrong. An audience's attention has a shelf life. Studies show that in a typical presentation, you have about 10 minutes before people start to check out. After 9 minutes and 59 seconds, you have to do something to regain their attention, something emotional, something relevant, something that acts as a hook to reset the clock. And here's another truth about attention that might change the way you work forever: the brain cannot multitask. Not when it comes to paying attention, anyway. What we think of as multitasking is actually rapid task switching. Every time you switch your attention from your homework to a text message and back again, your brain has to go through a 4-step process. It has to disengage from the first task, alert itself that it's shifting, activate the rules for the new task, and then engage. This process isn't free. It takes time, several tenths of a second for every switch. Studies show that a person who is interrupted takes 50% longer to complete a task and makes up to 50% more errors. Trying to talk on a cell phone while driving? It's not just dangerous, it's as impairing as driving drunk. Your brain is a sequential processor. One thing at a time. That's the rule. Once you've captured your brain's attention, how do you turn that fleeting moment into a lasting memory? This leads us to two of the most practical rules in the book. Rule 5, repeat to remember, and Rule 6, remember to repeat. Most of what we learn is forgotten within minutes. Think of your short-term or working memory as a small desktop where you can process a few pieces of information at a time. The typical brain can hold about 7 pieces of information for less than 30 seconds. If nothing happens to that information in those 30 seconds, it vanishes forever. So how do you move information from that temporary desktop into the vast, long-term storage of the brain? The secret is repetition. But not just any kind of repetition. Cramming information all at once is like trying to cram a week's worth of groceries into a small refrigerator in one go. It's messy and inefficient. The most powerful way to fix a memory into the brain is through spaced repetition. Learning occurs best when new information is incorporated gradually and repeated in timed intervals. When you first learn something, the memory is fragile. If you deliberately re-expose yourself to that information after a certain amount of time has passed, say, a few hours, then a day, then a few days, the memory becomes stronger and more durable. This process, called consolidation, can take a surprisingly long time. The conversation between the hippocampus where short-term memories are processed and the cortex where long-term memories are stored isn't a quick chat. It's a dialogue that can last for years. This is why homework, at its best, is so important. It's a form of forced repetition. A better system would be to build this repetition directly into the school day, reviewing information cyclically and deliberately. Of course, for any of this to work, your brain needs to be in the right state. And that brings us to two of the most overlooked aspects of our mental performance: sleep and stress. Let's start with Rule 7. Sleep well, think well. We spend a third of our lives doing it, yet most of us treat sleep as a luxury, or worse, a waste of time. Brain science tells us this is a catastrophic mistake. When you're asleep, your brain is anything but resting. It's buzzing with activity, with neurons firing in rhythmic patterns, often replaying and making sense of the things you learned during the day. What's really happening during sleep is a fierce battle between two opposing armies in your head. One army, the circadian arousal system, is doing everything it can to keep you awake. The other, the homeostatic sleep drive, is trying to put you to sleep. This war cycles every 24 hours. The longer you're awake, the stronger the sleep drive becomes, until it finally wins, and you fall asleep. And the longer you're asleep, the stronger the arousal system becomes, until it wins, and you wake up. Loss of sleep isn't a badge of honor, it's a brain drain. Sleep loss cripples your attention, your executive function, your memory, your logical reasoning, nearly every cognitive function we can measure. One bad night of sleep can decrease your cognitive performance by 30%. Restrict yourself to 6 hours of sleep a night for just 5 days, and your brain will perform as if you've stayed awake for 48 hours straight. And what about that groggy feeling you get around 3 p.m.? That's not just you. It's a universal biological signal called the nap zone. It's a point in the day where the battle between your two internal armies reaches a stalemate, and your brain desperately wants to take a break. Fighting through it is often a losing battle. The science is clear. A short nap can dramatically boost performance. A NASA study found that a 26-minute nap improved pilot performance by 34%. So, the next time you feel that afternoon dip, remember that your brain isn't being lazy, it's asking for what it needs. Just as sleep is essential for a healthy brain, the wrong kind of stress can be devastating. This is Rule 8. Stressed brains don't learn the same way. Our bodies have an amazing stress response system. When faced with a threat, like a saber-toothed tiger, your brain signals your adrenal glands to release adrenaline and cortisol. This is the fight or flight response, and it's designed for short-term, life-threatening situations. It prepares your body to act fast. The problem is, our modern lives are filled with chronic stress, work deadlines, traffic, financial worries, relationship conflicts. Our stress system wasn't built for that. When stress hormones like cortisol hang around for too long, they become toxic. Adrenaline can create scars in your blood vessels, leading to heart attacks and strokes. And cortisol is particularly damaging to the hippocampus, that critical region for learning and memory. It can disconnect neural networks, stop the birth of new neurons, and under extreme conditions, even kill brain cells. What's the worst kind of stress? The feeling that you have no control over the problem. This is the essence of learned helplessness, a state where the brain essentially gives up. This has huge implications for our lives. An emotionally unstable home environment is one of the biggest predictors of poor academic performance, because it creates a sense of chronic, uncontrollable stress for a child. The same is true in the workplace. The most toxic work environment is one where you have high demands but low control. Our brain doesn't just process abstract thoughts, it experiences the world through a rich tapestry of senses. But we don't treat our senses equally. This brings us to the next set of rules, which govern how we perceive our world. Let's start with Rule 9. Stimulate more of the senses. Our senses didn't evolve to work in isolation. They evolved to work together, constantly influencing each other to create a unified picture of the world. You can see this in something called the McGurk effect. If you watch a video of someone saying the syllable ga, but the sound you hear is ba, what do you perceive? Your brain, trying to make sense of the contradiction, will likely hear d, a complete fabrication, a compromise between what it sees and what it hears. Because our brains are built for a multisensory world, we learn best when we stimulate multiple senses at once. Students who are taught with both words and pictures learn better than those taught with words alone. In one study, groups given multisensory presentations came up with 50 to 75% more creative solutions to a problem than groups who received unisensory information. The effect is super additive, meaning the whole is greater than the sum of its parts. Of all our senses, smell holds a unique power. Odor signals bypass the brain's normal sensory switchboard, the thalamus, and go directly to key areas like the amygdala, the brain's emotional supervisor. This is why a certain smell can trigger a vivid, emotional memory from years ago, something known as the Proust effect. But even with all our senses working together, one sense reigns supreme. This is Rule 10. Vision trumps all other senses. Vision is by far our most dominant sense, taking up a staggering half of our brain's resources. We don't see with our eyes, we see with our brains. And what we perceive isn't a perfect, camera-like recording of the world. It's an interpretation, a best guess based on incomplete information and past experiences. Your brain is constantly filling in gaps and making things up. For example, each of your eyes has a blind spot where the optic nerve connects to the retina. You should see two black holes in your field of vision, but you don't. Why? Because your brain looks at the surrounding information and paints in what it thinks should be there. You are, in a very real sense, hallucinating right now. Because vision is so dominant, it profoundly affects our other senses. Remember the wine tasters? A group of experts at the University of Bordeaux were given a white wine that had been colored with a tasteless, odorless red dye. Every single one of them described it using the vocabulary for red wines. Their eyes completely overrode their highly trained noses and taste buds. This visual dominance has a huge impact on learning. The pictorial superiority effect is one of the most robust findings in psychology. Put simply, we remember pictures far better than we remember words. If you hear a piece of information, you'll remember about 10% of it 3 days later. Add a picture, and you'll remember 65%. Why is text so inefficient? Because to your brain, words are just a collection of tiny, complex pictures. Your brain has to identify every feature of every letter before it can assemble the word. Reading creates a bottleneck. This is why text-heavy PowerPoint presentations with endless bullet points are one of the worst possible ways to communicate information. Our brains are not designed for it. We've talked about how our brains evolved, how they learn, how they're wired, and how they perceive the world. But we've saved one of the most powerful and hopeful rules for last. It's a rule that is most visible in the youngest members of our species, but it's a rule that never has to leave us. This is Rule 12. We are powerful and natural explorers. If you want a model for how humans are designed to learn, don't look at a college classroom. Look at a baby. Babies aren't passive sponges, just soaking up information. They are active scientists. From the moment they are born, they are driven by an insatiable curiosity, an intense need to understand their world. They learn by doing what scientists do. They observe, form a hypothesis, design an experiment, and draw a conclusion. When a baby repeatedly drops a spoon from her high chair, she's not just making a mess. She's testing the laws of gravity. When a toddler points at a bee after being told it's dangerous, then grabs it the second your back is turned, he's running an experiment on cause and effect and your attention. This drive to explore is so deeply stitched into our brains that it persists throughout our lives, if we let it. We now know that parts of the adult brain remain as flexible and malleable as a baby's brain. We can continue to grow new connections and even new neurons throughout our lives, allowing us to be lifelong learners. The Nobel Prize-winning scientists Edmund Fisher and Edwin Krebs were still running powerful, productive labs well into their 70s, driven by the same boundless curiosity they had as young men. The great tragedy is that our educational and corporate environments often crush this natural exploratory instinct. From the first grade, we learn that the goal isn't to be curious, but to get an A. We learn to ask, what do I need to know to pass the test? Instead of what am I fascinated by? But it doesn't have to be this way. The companies that thrive, like Google, which famously gives its employees 20% time to work on any project that interests them, understand that curiosity is the engine of innovation. Our brains were not built for boredom. They were built for wonder. They were built to explore, to question, to experiment, and to never stop learning. Commentary. As we've journeyed through these 12 rules, a single, powerful idea emerges, one that I believe is the heart of John Medina's message. It's this: our brains have a factory setting. For millions of years, they were optimized for a very specific type of world, one filled with movement, constant threats, and rich, multisensory experiences. The modern world we've built, our schools, our offices, our cities, is a radical departure from that original design. And much of our frustration, our inefficiency, and our struggles with learning come from this fundamental mismatch. What Brain Rules offers us is not just a list of tips and tricks. It offers us a path back to ourselves. It gives us permission to work with our brains, instead of constantly fighting against them. It reminds us that we are biological creatures, shaped by an ancient past, and that honoring that biology is the key to unlocking our full potential. The book is a quiet revolution. It challenges us to rethink everything. Why do we force students to sit still for hours when we know their brains learn best while in motion? Why do we cram our presentations with bullet points and text when we know that vision is our most powerful sense? Why do we praise multitasking when we know it cripples productivity and increases errors? The most profound lesson, for me, is the one on exploration. In a world that so often prizes conformity and specialization, Medina reminds us that our greatest strength is our curiosity. That scientific, hypothesis-testing instinct we see so clearly in babies is not something we are meant to outgrow. It is the very engine of learning and discovery. It's what allows us to adapt, to innovate, and to find joy in the lifelong process of understanding our world. This book is a call to protect that instinct in our children, and to rediscover it in ourselves. So, how can you start applying these powerful ideas to your own life, right now? It doesn't require a radical overhaul. Small changes, aligned with your brain's natural tendencies, can make a huge difference. Here are 3 simple things you can try today. First, embrace movement. If you're stuck on a problem or trying to learn something new, get up and walk. Our brains don't just work better when we exercise, they think better when we move. Don't separate your physical life from your mental life. Integrate them. Second, honor the 10-minute rule. Whether you're studying for an exam or sitting in a meeting, your attention works in 10-minute bursts. When you feel your focus start to wane, don't just push through it. Take a 60-second break. Shift your focus. Look at a picture related to the topic. Ask a question. Do something to re-engage your brain before diving back in. And third, think in pictures. Our brains are visual processors above all else. When you want to remember something, don't just write it down in words. Draw it. Create a mental image. The more you can turn abstract information into a visual story, the more likely you are to remember it. That was a summary of Brain Rules by John Medina. We've touched on the key principles today, but I have to be honest with you, listening to a summary is like looking at a travel brochure. It can show you the sights, but it can't replace the experience of actually taking the journey. The real magic of this book is in the stories, the science, and the aha moments that happen when a particular idea connects with your own life in a way you didn't expect. This summary is your map, designed to help you see if this is a journey worth taking. If anything we've talked about has sparked your curiosity, I encourage you to grab a copy. Reading it isn't just about learning facts about your brain, it's about starting a conversation with it, and that's an experience that can genuinely change the way you live. And, if you found this summary valuable, please take a moment to like and subscribe. Each week, we dive into another life-changing book from the world's most brilliant minds. By subscribing, you're not just joining a channel, you're joining a community of lifelong learners. Let's keep exploring together.